Welcome to CS1033 Program Fundamentals. We'll be discussing data structures with dictionaries now. We have completed our discussion on lists, tuples, and sets. Let me give the content of our discussion. I'll introduce the dictionary data structure to you, and then look at how to create dictionaries and the adding, removing, and accessing of elements in a dictionary, and some of the useful functions that we have for the dictionaries provided by Python as built-in functions. So in the primary data types and the structured data types that we have discussed, list, tuple, sets, we store every data item as a single value. So in the structure, we have multiple items, but each item, say, take a set, set has set of values, and each of these elements in the set is a single value. Dictionaries are fundamentally different from that in each data element is a pair of values. One is called a key, the other part is called the value. So from an application point of view, we are discussing problem solving. So for problem solving purposes, we use data, and the data that we use for problem solving is in the value part, and the key part in the element is for organizing and structuring this data. So as noted here, we have this key in our data element, so we can have highly efficient access to data, highly efficient reorganization of data, and the availability of this key allows the Python system to internally come up with very efficient ways of storing this data. The dictionary type is an unordered collection. Okay, so it's a collection, it's unordered, so we can't essentially use the index operator because it's unordered. It's just like the sets. The actual value of the dictionary data structure is in the key, which allows us access. So in a way, the key works like an index. But here the important part is in the ordered data structures we have discussed previously, the index is provided by the system. Python says this is index 0, the first element. This is index 1, the second element, like that. But here we decide what the key is, and therefore the ordering is entirely under our control. So therefore, a dictionary is quite a versatile and powerful data structure. And what happens with the key and the value is, this is similar to the dictionaries you are familiar with. So if you take a dictionary, you would want to look up a particular word, and dictionaries are printed, or if it is a soft copy, is available in the alphabetical order. So you can quickly get to the word you want, and the word, for example, the word unordered, there will be a dictionary entry explaining what that means. That is the value part. To create dictionaries in Python, we have two methods. One is to use the curly brackets, just like sets. So you can now understand sets are also unordered, just like dictionaries. Other one is to use the built-in function dict. And when we create a dictionary using the curly bracket approach, we will separate out our data elements using commas. So each data element is colon separated. So that's what is shown here. We have the key, and then a colon, and then the value. So the key part in the dictionary have it has some important properties. It must be unique. Okay, so it's a key value. It must be unique, and it should also be immutable. In contrast to that, if you take the value part, it can be any data type, and there is no requirement for it to be unique. Other technique of building a dictionary is to use the Python built-in function dict, and we'll see some examples of usage of these techniques. If you want to create a M dictionary, we can simply use curly braces, and of course we will have no data elements inside. Now, yeah, so I want to highlight some issue at this point. So if you create a dictionary in that manner, at the very beginning, we would not know whether it is a set or a dictionary. It doesn't matter, because set or dictionary, it is empty. It's an empty, unordered collection. So that definition fits to the both set as well as the dictionary. So I have some examples of creating dictionaries here. For example, now I'm using the curly bracket approach. Here, the two curly brackets are there, and the input here, the key is an integer value, 1, 2, 3, like that, and then the value part is a string. So I want to highlight you the use of quotation marks here for the creation of strings, because I want to use the single quote inside the string. So that's what I'm saying, the use of different ways to specify a string. So we can use the apostrophe. Otherwise, no, if I put the apostrophe like this and create a string, it will, and if I have another apostrophe here and here for the string, Python will get totally confused. So that doesn't happen, because it correctly matches opening double quotation with the ending double quotation, and everything in between is a string. So this is one way of creating a dictionary. And we can use mixed data types for the key also. It just need to be unique only. Okay, so here I have a string 1D, 2D, and then numeric value as the key values. And as I already mentioned, the value part can be anything: a string here, another string here, and a list here, comma separated set of values. So generally, we will use the term index to refer to this this value which points to data. Okay, but to avoid any confusion, in dictionaries we use the term key. So I have highlighted that, the usage of the term key, and the index term is not generally used when you're talking about the dictionary. As noted here, we can create empty directories simply by using the braces with nothing inside, or calling the dict function with no argument. So my suggestion is, if you want to create an empty dictionary, use the dict function, not the curly braces, because most often we use that for creating empty sets. Universally, the notation for set is the curly bracket. Okay, so if you're writing mathematical equations and things like that, not just programming, you will use the curly braces. So, so my suggestion is to leave aside the curly braces for set notation when you are denoting an empty set, but use the dict function, the built-in function. When we want to create a dictionary, so most often either we will start with the empty dictionary and then keep on adding elements one by one, or we might actually create an element using a list. So we can either pass a list variable, or as I'm doing here, I'm directly passing the list as an argument. So, so list is iterable, and the dictionary function will correctly process it by iterating over the list and taking individual elements and creating the index value part. So every individual item in the list should be a tuple, a pair, type tuple, and the first one would be the first part of the tuple would be the key, and the second part would be the value. So we have to make sure that the first parts are not duplicated. They should all be unique. So if you run this code and print it, this is what you will see. Okay, a list has been passed, but it has been converted into a proper dictionary with column separated data items. Now let's look at quickly the adding of elements to a dictionary. Again, we have two methods available to us. One is to directly access using the key. Okay, so I'm careful not to use the term index. We use the key for direct access to an element. Other method is, of course, to use the update method. It's a Python built-in function. Here are the examples of doing it. So you can see I have a dictionary created using tt. This is the variable name. So I have said not to do that, but for ease of creating slide, I have used the curly braces, and then I'm adding these values. So the Python would know that so at this point, so please pay careful attention to what's available as input to the Python interpreter. So at this point, Python knows, okay, I have variable called tt, and it can be either a set or a dictionary. It does not know which one is which. It can be either set or dictionary, and it knows it is empty. And then when we do this assignment, it knows, okay, tt is a dictionary, not a set. Okay, this is not how we add elements to set. So, and it knows, okay, this is the key value, and this is the key for the dictionary. So I'm making a dictionary, and then this is the key, and this is the data value. And so the notation allows the Python interpreter to decide at this point whether it is working with a set or a dictionary. And yeah, so if I print this variable, now it will be correctly printed like a normal dictionary with the colon separation. Okay, so these are the key values. We can use the use this technique now to update the dictionary with new values. So we simply keep on adding values to the dictionary in this manner. Okay, so I had a new value. Okay, and then if I want to change the value at that particular key, I just use the same key and give the changed value. Okay, so this you can see here in the output. In the first print of the dictionary, you have the value for the key value 4, you have the data value mapped as mentoring, and the second one, now we have an update, it is now online mentoring. Okay. The update function is the other technique that we use to change contents in a dictionary. We need to pass an iterable list. Okay, iterable list. So we can pass it either as a variable, or in this case, I have just created it directly. So as I explained earlier, we have each element in the list as a tuple, pair type tuple, and the first value is the index, second value is the value. First value is the key value, second one is the data value, and it will correctly update. So I have now updated the value for the first and second data elements from program to CS programming and maths to MA maths, and you can see those two have been correctly updated, while the third one, I didn't do anything, remains the same. So what would happen if you don't have the key already existing? Okay, so then it gets added as a new element. Okay, so here I'm calling update. Okay, I'm calling update with a key which is not there. Okay, so I only have keys up to 1, 2, 3, 4, right? And the addition of new elements to the dictionary happens through, again, the update. So update has a dual purpose. One is to update existing elements with a new data part for existing key, to give a new data part. Also to add a brand new element, data element to the dictionary. Okay, so that is what is happening here now. You have the civil engineering mechanics added as item number 5. Okay, those are the techniques in which we create and add elements to a dictionary. Let's look at the removal of elements from a dictionary. We have 4 techniques available. The delete keyword and 3 built-in functions: pop, pop item, and the clear. Okay, so if you look at the delete keyword, we can do the deletion using a keyword. Using a key value. So there are again 2 ways of, if you are using the delete keyword. So you can think of it as operator, delete operator. And if you are using delete operator, we have 2 methods of using it. So either we specify the relevant key and delete a specific entry, or we can delete the entire dictionary. Okay, so we must remember, if we delete a dictionary, it's gone, it's no longer available in the program. Okay, not even as an empty directory. So that you must be very careful about that. If you use the delete keyword to delete a dictionary, it's completely removed from the system. So Python, if you refer to it again, Python will say no, not available. Okay, but it may be that you don't want to completely delete it, you want to maybe remove the items. For that we have different built-in functions available, right? So let's look at the next method of using the pop function. So here we can use the built-in function pop and specify the key as an argument. So when we give the key, the system will search through the dictionary to find the matching key value, the key value that matches to the key we have specified, and then get the corresponding data value and return that to us. While doing that, it will also delete the entry from the dictionary. So pop will get the value as well as remove the value from the dictionary. The difference between pop and pop item is that it will return so let me show you the example here. Okay, so let's look at the example here. So we have a dictionary A, which has the items 1, 2, 3, 4 are the keys, and these are 4 names. And when I print the dictionary, I should have the full dictionary printed. After that, I'm going to delete the dictionary, and then I'll try and print it again. Let's see what happens. Okay, so you can see first time I print, I get the full dictionary printed here. Okay, the full dictionary is printed. But this is an error message that is for the line 3. Okay, so this part, let me mark it down, this part, that is for line 3. So it says name error. Okay, so because I had deleted this dictionary, the Python system removes all reference to the variable also. So there is no variable actually now. Now, moving forward to the second example here. So I have the dictionary here with all the indexes are here 1, 2, 3, 4, 5 integers, and they have corresponding data values of strings for the first 4, and the 5th element is a dictionary by itself. Okay, so this is a dictionary by itself, and you have strings as keys and strings as data values. Okay, let's see what gets printed when you print this particular dictionary, and you can see it correctly prints the embedded dictionary also. Okay, embedded dictionary also is correctly printed. And now I will delete from B the the entry corresponding to the key 3. Okay, so I'm using delete keyword with the key value 3, and this should get removed. Okay, so you can see that is what happens when I print. Okay, let's see how we could delete the elements from the nested directory. Okay, so we had a nested directory here. 5th element, the element with the key value 5 has a embedded directory which has 2 keys, Eve and Frank. So now if I ask to delete the entry with the matching key Frank for the matching key 5, it will correctly delete that. So you can see now it only has Eve here. Okay. Let me now show you the built-in function pop with the example. So here I am using the keyword 2, key value 2, and let's see what happens. Okay, so just remind you about our dictionaries. At this point in time, the dictionary has 1, 2, 4, 5 as key values and the corresponding data values. Okay, because 3 we have deleted already, and B and the element with the key value frank from the 5th element, we have deleted that also. So so you can see now the here I use the built-in function pop and ask to get the value with the key 2. Okay, and then I'm going to print the dictionary. Okay, after this operation, after the pop operation, I'm going to print the dictionary as well as the value that was taken out. Okay, and you can see the output here. Now when I print the dictionary B, the item with the key value 2 is now gone. Okay, so it has been removed. It has been removed, and the value Bob has been returned to me. Okay, this is the return value. Now, similarly, I have the built-in function pop item. Okay, so you can see there also now actually I'm asking what I do is I here I insert a new element to the dictionary. Key is 6, data value is George. So after that I call pop item. Okay, I call pop item. So you can see I'm not specifying a key value here. Okay, pop item is a built-in function that does not take a key value. Okay, so that's the big difference between the pop and pop item. Okay, pop function needs a key value. Pop item you don't give a key value. So the idea is now when you say pop item, it will return to you a random value. But if you test this with the Python programming system, you will find always it will return the last item added to the dictionary. Okay, so that's its normal behavior. We can change that behavior by modifying the Python runtime, but generally this is what happens. So when I call bpop item, 2 things happen. Now after that I actually print the dictionary and the value that get popped. So I want to highlight a difference from last time. So now I didn't say which one to pop. Some value gets popped, and this time not just the value but the full item is given. Okay, full item. So you can see it gives the key and the corresponding mapped value also. And as before, the particular item has been removed from the dictionary. Okay, so that is what I have summarized here. The pop method will return the value from the dictionary and delete the full entry. Pop item will return an arbitrary element. So it should ideally return some random element as a tuple, not as a, here it is given as a value from the dictionary. Here it is given as a tuple, that is as a full key value pair. And it will again, so just like in pop, here also pop item will also delete the full entry. Okay, and then we have the clear method that will delete all the items from the dictionary at once, so you don't have to do it one by one. And the big difference between clear and delete is still the dictionary is available. So let's look at that example. Yeah. So we have Yeah, we have looked at that deleting earlier. So with the error message, yeah. So here it gives error message when you delete and try to access because it's gone. But if you use clear, it will give you an empty dictionary. Okay. That is what you have here. So when you call clear, it empties out. Now you can refer to the variable. If you use del for deletion and refer to b, it will give a runtime error, but now it will nicely print an empty dictionary. Of course, you don't know whether this is a dictionary, empty dictionary, or an empty set. As I said earlier, both have same semantics or same meaning. Nothing there is unordered, mutable data structure. So let's look at accessing individual elements in the dictionary. So I have noted this earlier also. You can use the key as the index now. So I'm using the term index here, okay, and put it in the square bracket. Or you can use the built-in function get. Okay, so yeah, use of get built-in function will remove any confusion you may have whether you are doing array access or whether you are doing directory access. But no, you should not get confused with the use of square brackets for accessing of contents from a dictionary. So here's how you do that. Okay. So this is what I want to like highlight about the confusion. So because if the key values are integers, yeah, it looks like you are doing a array item access because it is a integer value. So then you can't differentiate between whether it's a key or an index. Okay. Now, when you do this type of access, we have to be careful that if the key is not present, it will give a runtime error. It will give a runtime error. Whereas, so if you are using the built-in function, it will not generate any such errors when you try to access elements. So here's the example code on how it works. So I have the okay, so I have the dictionary here defined as storage with the with 4 elements. Now I will access the element with the key value 2, and it should print it without error. Okay, then I'm going to create I'm going to update the dictionary with the key value 5 and the value none. And yeah, earlier there was no key value 5, so it should get the directory dictionary should get updated. Okay, and then if I try to access the element with the key value 5, I should be successful in that. Then I will try to access the element in the key value 6. Of course, as you know, there is no such key value. So let's see what the outcome is. Let's go and look at that. Okay, so you can see if I access 2, I should get cache. So that is happening here. That's okay. If I use the get method again, no, I should get the cache because it's the same way, same access method. This is using the square brackets and this is using the built-in function. Now, if I try to get the element at 5, which I just entered, I should get none. Yes, it's happening. And yeah, this, the reason why I put the string none is to show you this particular situation. Now, I'm trying to access the element with the key 6 and I'm returned none. Okay, I'm returned none. So these two are two different nuns. Okay, so this none is actually a string I have stored in the dictionary. Okay, this none is a value that is being returned by the Python system saying there's nothing here. Okay, so I just want to like use these examples to show you the kind of confusion that could happen when you write programs. Python, you should be aware like the values that Python returns. For example, Python returns this value called none. So you should be very careful if you use the same literal value for any application purpose, like I have done here, like none. So this will lead to huge confusion. Okay, because these two nuns are two different things. This is actually a string value. This is a value from the Python system saying there is nothing there. Yeah. So I have now this code shows that I have updated the storage with a new entry. So the earlier entry, the second entry which had cache, I have updated this second entry which earlier had cache with a embedded dictionary. Okay, so it now has 3 entries, 2.1, 2.2, 2.3. These are the key values and they map to level 1 cache, level 2 cache, level 3 cache, 3 strings. And now I can access simply by referring to the element with the key value 2 and within that the element with key value 2.2. So I should get the L2 cache printed. This, yeah, that's what I get printed, L2 cache. Okay. So this is how you can access dictionary content using the key as an index. We have several useful functions from the Python system given as built-in functions, which we can use for programming tasks. Mind you, many of these functions we can implement ourselves by taking the, for example, take the dictionary, iterate through it to find out what are the elements. So you can, for example, do a pop item. Okay, you can do a pop item, iterating through dictionary and count until you get the dictionary emptied out. At that point, you know the length of dictionary. Okay, so you can implement your own methods to give this functionality. But of course, the Python built-in functions are much faster in execution. Then we have another function called keys, which will return a new object that will have all the keys in the dictionary. Okay, so remember, a dictionary is a data structure with a set of data elements where each data element have a key value, a key and a key part and a value part. So if I just want all the keys extracted, okay, from the dictionary, I can use this function. It will return to me all the keys. Similarly, if I want all the values extracted, I'll be return this new object with all the values. Okay. And I can use this third function, items, which will return to me an object with the items in dictionary. Okay, so each one given to me as a tuple. Okay, so here it won't be a dictionary item. So if I get all the items, I will have both the key and the value. So here I get on the keys, here I get on the values, here I get both keys and values, but it will come not as a dictionary entry, but as a simple tuple. So a comma separated pair of values. Some more functions. So as we discussed earlier, copy will give me a shallow copy. Okay, just like in earlier case. So if you change, it will not change the original. If you change the copy, it will not change the original. If you change the original, the copy will not get changed. And then the sorted, it will return the keys in sorted order. Okay, mind you, sorted will not return to me a sorted dictionary. It will return to me the sorted keys. So what you get is just a regular list as the result. Okay. So we have another function called from keys. We have to give two arguments. So the first argument, that we pass on to the function is a sequence of items, and the second argument, which is optional, so we can use it for the value part of the dictionary. Okay, so so essentially what happens here is if you have a dictionary and if you want to extract a sub dictionary out of that, you can use this from keys function. Let's say you have a dictionary, language dictionary. So it has entries for it has entries for words starting with the letter A, entries for letters starting with the letter B, like that. Okay, so on and so forth. Suppose you just want the smaller dictionary just for the words starting with the letter A. Okay, so then by giving the sequence of items as the keys in the first argument, you can get such a sub directory, sub dictionary written to you as the result. I'm explaining this actually for completeness sake, but with dictionaries, mostly we would be using for problem solving the built-in functions like len, keys to get a list of keys, values to get a list of values. Occasionally we might use items, but yeah, in most cases we may not want to do that. Copy, we use that often. Sorted, sometimes we might use it. Okay, from keys and the which I just explained, and the set default are not very often used as functions for solving problems. We might have specific applications where that is required, but most often not. Okay, so let's see what happens with the set defaults. It takes two arguments. So what happens is it will return the values. It will return the value if the key value that you have given at the first argument is present in the dictionary. Okay. But if it is not there, because you might ask, what is the use of this? This is just dictionary access. So why do we need a function for that? Okay, because you can just give the key in square brackets and it will return to you the corresponding value, or you can use the get function. So to access the entries in the dictionary, the values in the dictionary. But the difference here is if the key is found, it will return the value. But if the key is not found, then it will insert the key into the dictionary as a new entry. Okay, so this is a very useful way of doing multiple things using a single Python function. Otherwise, you will have several instructions. So first of all, you will check, you will access the item by passing the key, and then you will check whether you got a result or whether you did not get a result. If the result is none. If the result is none, then you can then do the update. Okay. So either using the update method or using the square bracket and using the key at the index. So these multiple instructions are now simply put into a single instruction. Okay. So if you don't give an argument, only the key, then Python will give the default value none. Okay. So mind you, again, this is not a string. This is a defined value in Python. So I have all these examples I discussed here in a sample code, and the corresponding outputs are shown here. So let's see what happens. So here I print the dictionary, and then I print the length of dictionary. So length of dictionary should be 1. So you can check how many elements are there: 1, 2, 3, and 4, because this is a embedded dictionary. Let's see what the output is here. So the dictionary is printed here, and then the length is given as 4. So that is correct. I can then I call the keys function, and I am return an object. So I'm actually printing that in line number 5. Let's see what we have here. It is it's an object which is containing a list. Okay, so mind you, it is an object of the type dict keys. Okay, so what is returned to you is not a list. What is returned to you is an object of the type dict keys or dictionary keys, and internally that object has this data structure which is a list. Okay, that's a list of keys. And similarly, I can call the method built-in function values. I will be return an object. So let's look at what that object is. So that is a dict values object, dictionary values object. Within that object, I have a list. Okay, list of values, including another dictionary as one of the values. Okay. Right. Let's see. So this is for the items. Let's see what gets returned as items. So it is another object called dict items. That's an object. It has an internal data structure, which is a list of tuples. Okay, so this is a list of tuples. Each element is a tuple. Okay, mind you, each element is tuple, not a dictionary entry. These are dictionary entries separated by a colon. Then I have the copy to show you the shallow copy operation. Then I'm doing some printing of the dictionaries to show you what the changes are. And I have other function calls for sorted and from keys and set defaults. Okay, so I have a dictionary named origins with these entries. So bats, civets, camels, cats, like that. Okay, so these are the key values. Bats, the animal names are the key values, and I have Boolean value, true or false. Actually, this is this dictionary tells you which animals give you COVID like diseases. So bats, civets, and camels can pass it on, but not the cats. Cats are safe. Okay. So if I call sorted, I get a list returned to me. Okay. Very important. Remember this. It is a list that is returned to me, not an object. It's a basic list with the keys now in the sorted order. So B, C. So other three elements are C, but as you can see, camels, cat, civets, like that. Okay, in sorted order. And in this one, okay, so what I have done is actually call the from keys and given the two keys, cats and civets, and I am returned the entries for those two. Okay, so what is returned to me is actually a dictionary. Okay, so this is what I told you. I can get a sub dictionary returned to me. So from the main dictionary, and each item is a dictionary entry, key value pair is returned, and then as the last example, I am using the set default, where I am passing a key value pangolin and the corresponding data value false, and you can see what has happened to the new origins dictionary. So it has got the entry inserted because this entry was not there. So when it checked for the key was not there. So set defaults would enter the new item, new key, and because I have given a value, it has stored that value. If I have not given a value, it would have stored the value none in that. So those are examples of those built-in functions. Okay, so now that completes our discussion of the dictionary data structure. So let's have a quick comparison between sets and dictionaries. So as I said at the beginning, if you have empty set and if you have empty dictionary, you can't say which is which. Okay, so sets are created using curly brackets. Okay, so here's an example. You can put duplicate values, but it doesn't matter. Python system will remove the duplicates. Okay, so that's an automatic action. In a dictionary, similarly, you can create using curly brackets, but of course, now it is different. We have to give the key and value pairs. Okay, key and value pairs, and you can't have any duplicates. Okay. If you have any duplicates, then they will get removed automatically. Okay, so so you can specify them in the creation, but they will get removed when the dictionary is created by the Python system. And in other aspects, they are very much similar. No duplicate elements because the key is unique. They are mutable, so we can add and remove elements. But apart from those, very useful similarities, there's a big difference also. Okay, so the data elements in a set are immutable. So individual data elements are immutable. So think of a set as a bucket, and to this bucket you can put elements and you can remove elements from the bucket. So bucket itself is mutable. So that's why a set is mutable. But these elements you put to the set, they can't be mutable. So you can't put a data item which will get changed. Okay, so that is not allowed. So for example, list. Okay, list is mutable, so a list cannot be an element in the set. But string is not mutable, it's immutable, so you can have that as an element in the set. In contrast, dictionaries don't care. So any data value is allowed. It supports mutable data. So key. So when a key values to the map, when a key values map to a data value, that data value can be any mutable value. Only requirement is the key should be unique. So I have some additional sample code given here for you to try out and see how Python behaves. Okay, and to properly understand the use of the dictionary data structure for problem solving, I have a suggested exercise. Here again, this is to help people order items online. Okay, so the requirements are specified here. Remember, in the first lecture, I said when you are given a problem to solve, in problem solving, the big problem is trying to understand what the problem is. So you will get a description. So I'm saying that there is a resident who wants to send a request to central database, and these are the items of data that wants to be sent: mobile number, address, and a list of food items they want to purchase. So you should implement the database as a Python dictionary. So you have to figure out what should be the key here, okay, and what are the data, and then afterwards, this database should be processed and used for delivery of items. So essentially, the delivery plan should allow people who are delivering things to find the people by an address. Okay, because now if you are putting items to a central database, people will not put that in any order. No, they will just call up and send these details to database. But once you have packed the items for delivery, you don't want to just zigzag around and go here and there randomly. You want to go in a particular path. So you should be able to sort it by the maybe the lane, the house number in a particular lane, things like that. Okay, so that is the requirement. So yeah, I think when you do the exercise, some of the requirements you may have to just imagine. This is for practice purposes. But I have given a hint by showing you an output stream. Okay, so this is the database. So as you can see clearly, I have indexed it by the mobile number. Then I give the address. Okay, these are all roads near the university. Unfortunately, you have not been to the university so far. So sometimes you might end up staying in a rented place in one of these roads. And people can order various items. And so if you want to know, for example, so once you have a database like this, it is pretty useful. Okay, now for example, you want to find out in people in Molpe Road, what do they want to buy. So you can just run a very useful Python built-in function and get what they want. Okay. Yeah, for different roads you will have that kind of output. So this is what you should provide as the output. Okay. So yeah. So now we have completed discussion on lists, tuples, sets, and dictionaries. Then the last data structure we will discuss is the abstract data structure.